Good morning. It's Saturday morning. I am going to spend a little bit of time trying to bring my spirits up a little bit by reverse engineering some more of the 1991 game, The Summoning. So, what we're going to start out with here is we're going to start out by trying to figure out how the various overlays work for tiles. Um, Additionally, I've got some changes that I've made to the level renderer to try to make that work a little bit better, or rather for my rendering of levels. Um, so let's get started. Um, Today I'm also going to be listening to Hesitation Marks by Nine Inch Nails. Um, Pretty great album. Um, Definitely has its ups and downs, but otherwise pretty great. I know it's a little dark on my face here right now. Let's see, can I change that? A little bit, not so much. So let's go ahead and get started. I have loaded up my what's it called? Library called Dispersing. I'm going to go over some brief changes that I've recently made. I was able to figure out most of the way that the level rendering works, um, not using corners for the walls. I have not finished getting all of the tile rendering working. Before I get too much further in, let me show, move to a new window. I'm going to put out there, this is my old diagram of things. I've been working on exploring some of the overlays for the tiles. And you can see here, this item, and this item are the ones that I'm going to focus on just for now. This right here has tile flags set to 1 with the argument 14, which corresponds to number 1 plus frame 4. This corresponds to tile flags 1 argument 23. That corresponds to the offset number 1186 plus frame 2. And that's where things get a little bit confusing for me. And then over here, arg39 corresponds to the same thing, 10, but frame 9. So I'm not totally sure how to get at all of these from these argument numbers, but let's take a look. So if I take a look at the level using the Kaitai Struct Visualizer, you can see some of the changes that I've made to it. Let's zoom in here. Alright, so this is level 0. Recall this. The other thing, oh yeah, I also made a change to, let me pull up my Jupyter, yeah, whatever, got some issues there. Let me pop this JupyterLab out and show you precisely, here, let's start a new Pi312, okay, import dispersing. We'll import some more too, just in case. Okay, now ts equals dispersing the summoning. This is where I set up all of my database of loading in the various different resources and so on. So let's go ahead and load that. If we look at ts levels 0, this is my level map. I'll call that L0. I updated my CP437. It still doesn't do coordinates though. So if we look here, this is right there. If we take a look at our items here, each one of the items values, so the way that the levels layout is structured is it has the map, which defines the sprite, then it has a set of items or attributes or something like that that get added on. I believe that I have mistakenly named some of these, but I've been going back through using Ghidra to try to fix it. You'll note that Each one of these has an x and a y coordinate. Here, the x and the y coordinates, it's isometric, so it gets a little bit funny anyway in the way that we define them. The x and the y coordinates are reversed from what we see here. Oh, excuse me, one of those days, I suppose. But let's take a look at, I want to say x equals 2, y equals 22. We'll come back to that in just a second. So here, 5, 6, this is it right here. So I'm right now, I still haven't updated it to have to change it from tile flags to something better. Right now it's called tile flags movable object. Movable object is actually wrong. It's not a movable object. It is in fact an overlay. And this is the argument to that. So here, these are the two items in specific that we want to look at. 421 and 425. If we look over here, this is 421, this is 425. We can see that here. So 0, 1, 2, 3, 4. This is 21, this is 25. Okay, so this one is flagged as a level exit. And you'll see here it has the opcode, which gives us level 1 as our destination, with a destination x and y coordinates of 30 and 1. And remember, of course, the x and y are backwards in this. Or are they in this one? They might not be, actually. Anyway, opcode is 4. We can look at that and see what the opcode is in just a moment, but then it also comes with a level value. Now, this is where it gets interesting. So this was 4. This is 5. So 5, this is, what was that one, 25? I know, I could just put a grid on there. 25, 24, 23, 22, 21, 20, 18, 19, 18, 17, 16. Did I count backwards correctly? So that's where we are here, 5 and 16. If we look over here, that gives us that right there. Yeah, so we've got 5 and 16 and 5 and 18. They're separated by 2. This one has flags movable object 14, flags movable object 23. So looking in the code, and 519. Ooh. 519 and 518. You know what? I'm going to go ahead and I am going to update the 2CP437 to add on. Oh wow, look at all that. Something went wrong with IntelliCode activation. Okay, let's go back to my 2CP437. What we'll do is we're actually going to add on 0 through 9 for all of these things. So, new string equals B, hold on, new string, yeah, this nice little list comprehension is not going to survive that well. Okay, for row in self.tiles, for call in row. Oh yeah, look at that, the autopilot's getting in the way. So for each column, nope, don't want to do that. New string components equal to that. New string components dot append calls. So calls dot append. Let's see, for I that at the very first one though, so that might be a little bit easier than I thought. Okay, for call in row, so here the new string components is equal to space. I know there's a way to do this with iter tools and all that nonsense. We only want the last one, so new string components is equal to a list comprehension of string of I minus 1. Yeah, that should do it for range, and yeah, that should do it. Why is that? String is not defined. What? That's probably going to be okay. For I row in enumerate self.tiles, calls is equal to string. Oh, wait. This needs to be a double list. We need to have a space at the start. Okay, I think that should do it. But you know what? I'm going to take this out here. Oops. I am really not on my game today. But I guess that's why we have these Saturday morning goof-offs, right? L0. Okay, so let's see. New string components. Okay, that should do it. Oh, do I need to encode this in CP437? Maybe. Okay, now let's do, what is that? Oh, that's just a piece of gunk on my monitor. Okay, so now let's do this for each of our rows. Calls equals string of row. Oh, and this needs to be string of I minus 1. Yep, dot encode. Calls dot append tile map call. And then this would be b dot join. And actually, I don't need the. Yeah, that goes at the outside, so this will not be that. This will be just b dot join. No. This new string component b dot join calls. All right. Now let's see if this works. Why is enumerate not working? Oh, right, because Pylance isn't working as a whole. All right, so let's restart this kernel. Let's see if we can get our grid there, and then finally reel ourselves back in. Byte-like object, string found. Yeah, of course. And finally, we'll have a grid output for our CP437. Oh, that sure didn't work. No, because I've got it backwards. Alright, so now 525 goes right there. Okay, makes sense. So 5. Is it 0 indexed? I think it is, but let me double check. Yeah, it is 0 indexed. Okay. Alright, so let's get back to this. If we look over here, this is my old rendering. Let's see, is there any... Okay, so this one is interesting. I also want to note, I still don't know how this gets rendered, because that tile still shows up as just a standard tile, so it's possible that the level exit does two things, that it changes the, that it both changes the rendering and it adds the procedure. But anyway, let's go back through here. Let's come up with all of our tile flag's movable object values. So here, let's delete this, L0 dot, and let's see, what's my path here? It's not the most, yeah, items. Right, level record. No, level asset? Yeah. Okay, so for item in L0, if item dot info dot floor flags dot value is not equal to 1, continue. Otherwise, print item info floor flags dot floor args. Okay, so these are all of item data has no object attribute info. Oh, is that the very last one? Yeah, because it's 255. Okay. So the last one will always be blank. Okay, so these are all the different items that are located throughout this level. Sorry, I gotta respond to a text message. Okay. An all-time low. Alright. Why don't we... So first item... Here, let's do an F string because they're so cool. We'll do item.info.x. Why do I need a... I don't need a parenthesis there. I want the parenthesis there. Item.info.y. Okay, it's not the info that has it, it's just item. Okay. So these are all the different items that are supposedly movable floor objects. So 222. So let's load up our emulator and find them. Oh, hey Rugs, good to see you. Today I'm doing something a little bit different. I am reverse engineering an old video game. I'm in fact now just loading up the emulator to pull it up so that I can compare what I found in the file formats with the actual display on the screen. Things are going okay. It's been, I don't know, a bit of a week. It's been, I had a lot of driving to do for spring break. Took the kids up, see some family. And I am sick of driving. So I gotta get my, let's see, gotta get the manual up. Yeah, same here. Real, bit of a bummer, to be honest. Well, no, not a bummer. I actually had a really good time, but it really, really sick of driving. Alright, if I can get this to load up, I gotta get to the copy protection. Yeah, invalid glyph index. Thanks, MUPDF. Alright, let's do this. Let's see, page 2. Alright. There we go. Alright, I'm just going to select a character here. Johansson. We're going to skip the opening and just go right here, because what we want is we want to figure out what each one of these items corresponds to. Now, in order to do that, I think my best bet is going to be I'm going to do a bunch of screenshots, and then I will assemble those, and then I'll show how the different ooh, a chip you bought in C. Nice. What type of chip? The ESP32s or something? I'm going to start up here. Let's see. Is there a way to take a screenshot? Let's see. F12 plus P. Did that do it? Let's see. Oh, I can't even remember where it stores them. Where does it store them? Is this a flat pack? See, Snap DOSBox X. Okay. 1396 is the current one. Right, let's try again. Capture. This is not storing them there. Let's see, is it in the config? Debugger run, nope. Log file render main video. Captures. Let's see, is it in there? Ooh, an Arduino. Nice. What do you, what environment are you programming it in? Are you doing it with their, I forget what it's called, the CircuitPy? Is that the one? No, you said you're doing it in C. Let's see. I still can't figure out where it's saving these screenshots. You know, the nice thing about, I used to run it from, wait, capture format? No, that's not the one. Where does Snap DOSBox X store files? Let's see. Yeah, Snap. All right. That's what I thought. Oh, wait, no. Finding a bunch of other ones. You know what? Forget this. I'm just going to restart this. Do it from the, I'll do it from the, what? Yes, I want to quit now. I'm just going to do it from here because if I do it from here, it'll output it to the command line where it stores stuff. So, okay, it's going to take a second to get back in, but it should be worth it. Oh, nice. Yeah, I gotta say, make files are always the thing that hangs me up the most. If I ever have to write one from scratch, that's basically it. And I know everybody likes CMake and all that, but I have not gotten the hang of that one either. I gotta say, the thing, every single time I write a make file, I have to, I always make the exact same mistake every single time. And that is I use spaces instead of tabs. It's always, always annoying. I bring it on myself. All right, let's see. Now it wants page 19. Let's see, that one. Ponytail. Stanley Tucci. Ponytail. Feather hat. Okay, we'll select the character again. We'll just do Johansson again. Start the game. All right, now let me grab some screenshots, which I will then assemble, and we'll then figure out which items go where, and we can see based on the floor and all of that. Okay, Excalibur makes that so nice, by the way. Okay. Do you have a project that you're working on specifically? Or just still, are you doing like a hello world to get acquainted with it? Of course, they're right there. Okay. There's going to be some overlap in these. I just did a regular capture that time, right? So let's do take screenshot. So what we want to do is we want to come up with all of the items that are accessible. See, we've got all these different overlays on the screen here too. You can see like this torch, this water fountain. I don't know if those, I can't remember if those stones are overlays or not. I can't remember from looking at the tile images, the tile sprites. Okay. Now here's an object, which is also stored in the items array. Okay, now the other thing we gotta do here is we gotta go talk to the NPC because it turns out there's a big secret area in this room. So let's talk to our NPC. Did I get down here? I'm not sure I did, but I can overlay all these things, so. Okay, yeah. Oh, nice. Pin.io and voltage. It's fun stuff. It says, let's see. Oh, I'll show you in just a sec. What I'm trying to do is I've got the level format for this game mostly figured out, and I'm using Kaitai Struct for that. And what I want to do is finish up understanding, and here I'm going to pause this and I'll show you what I'm doing. What I want to do is I want to finish up understanding precisely how the level format maps in the file to, and here let me, Excalibur, new drawing in a new tab. I want to figure out how exactly that level format maps into the item, the display here. So it's got a set of tiles that it works with, and those tiles then have items on top of them, and it has annotations and so on. And I want to figure out how it stores the annotations specifically. Because if I can figure out how it stores the annotations, I can get a lot further on my way to rendering the image exactly, and I can also get it closer to figuring out the different stored procedures in the level. So it stores all these procedures, like operations that happen at different times and so on, or triggered by different events. And I want to figure out how it stores those so that I can well, understand better the level itself. Okay, now we've got... Oh, did I forget to... Okay, yeah, there we go. So now what I'm going to do is I'm going to drop the opacity on these so that I can line them up nicely. Oh, sorry, I forgot to have my Twitch chat open. So let's line that up. Yep, there we go. So this one might be a little bit trickier because I don't have as many visual cues. There we go. Yep, that one's lined up. Okay, so let's pull this one over here. Wait, where does that one line up with? Oh, right there. I don't need that one, do I? Nope. Okay, that one. Why is that one not lining up very well? Did that do it? Yeah. Oh, well, yeah, there's a project that'll help me with, but I gotta tell you, the project itself is not necessarily going anywhere. Like it's sort of a hobby. I've been exploring the way that this particular game that I played the heck out of when I was a kid, um, the way that it stores data, because I really enjoy reverse engineering file formats and stuff like that, which I use in my day job a fair bit. But no, it doesn't necessarily have a distinct destination other than the joy of doing it, which, you know, is what's keeping me going in sometimes. So really enjoy, sort of seeing how things are done and how people used to do things. This particular game was a very long game. It was super long, but I did beat it when I was a kid, 30 some years ago, and um, I keep thinking about it and just the way that they had to store so much information, and I find the engine itself pretty fascinating. It's a good opportunity to sort of test my ability to learn new things as well, and it's kind of like to be honest, it reminds me of like an exit room. All these puzzles that you have to solve, you have to figure out how to understand the file format given limited information and that sort of thing. So no, it's not necessarily a project that's going somewhere specifically, but it is one that I enjoy doing and that I have done a fair bit of. So now I think I've just about got this finished. There we go. All right, I think that'll do it. Now, that is our entire first, well, no, I think I want one more screenshot. I can't get it, can I? Yeah, I can't get it at this point. All right, let's leave that there. Now let's crank up the opacity. Now, how do I get this one? Let's send that one down. There we go. All right, now I've got basically the entire level. So we'll call this file this is my map. Let's toss this in my reverse engineering directory. All right, so now let's take a look at, oh, that's not right. That is, so let's drop the opacity there. No, I'm missing something there. Let's send it back. Let's see, do I have another one here that I could use for that? This one. There we go. All right, send that one to the back. Now we got to match it up. There we go. Okay. Let's get rid of that one for now. Send this one to the back. Let's drop the opacity. Yep, there we go. Okay. Now let's bring the opacity back up. Okay, so now we've got a full map. Great. So now, let's go back here. So this was a Microsoft DOS game. It was in 1991. One of the neat things about this is that you can do a fair bit of, like it's in real mode, which means that there was no memory protection. So there were all these really neat tricks that they did and whatnot for storing data in really confined spaces. Let's see. See if I can draw coordinate lines. Now the thing is that the aspect ratio of this is on VGA, and so the aspect ratio doesn't. Yeah, it did. I think it had. I think it was pretty good at 30 frames a second. But okay, let's see. We want this to be. Let's see if I can calibrate our grid right here. Okay. All right. So we've got our line there. Now let's go back to our map. 2 and 22. Go to 24. So let's see. And 22. I think that's that. So that's right. Man. Do I have a screenshot of that one? Let's send that backward. There we go. Okay. What? Great. I just messed it up. Alright, I think that's about as good as I can get it. And I think that is the annotation that we're seeing. Now that, of course, is the guy's head, but it looks like there's a tiny little annotation on the wall there. And that would fit, right? Yeah, it would. So that's 24. Down one and one to the left is 21. I think that's that one. But here, let's actually back up a little bit. Are there any duplicates here? We see 3 twice, at 10, 4, and 12, 7. 10, 4. I've really made a hash of this, huh? That's it right there. Okay. So 22 in Y. Or in X. So that's 0. That's 22 and 2. So that's that one. Yep. That's 24. 21, that's one to the left. And down one, that's 29. Let's go back to my other item here. I had figured out this was 39. Man. Looks like I've got a lot of confusing stuff on this. Sometimes I think the easiest way to do this is actually to change it and then see what changes, but 0 and 11. That's right here. 0 and 11 has 28. Where else has 28? Anywhere? No. So let's go back over here. That. Yep, right there. 0 and 11. That's it right there. So if that's right, then 0, 12 should also have an exit. Yes, and it does. Okay, so that right there, this will be our first note. We'll put 12, 0 as 28, or 11, 0 as 28. Okay, now one up, so that's 10, probably 2 over will be that one. Let's find that one. 2, 10 is 34. Does that work? 2, 10? Yeah. No, 34. It was not, no. Although all the work I'm doing right now is stored in an open source repository. Now, mind you, I've got a bunch, well, that's not entirely true. I have a bunch of stuff in Ghidra, the reverse engineering tool, that is not currently stored openly just because it includes the code for the underlying application, which I'm not putting out there. So let's see, 28 and 34. So now what we do is we go in here. Let's take a look at our data here. Properties. We've got wall decor 1, 2, and 3, and wall overlay tiles. So let's take a look at wall decor. Now the wall decor offset is 1186. So ts.resources.sprites 1186 plus 1. So this is wall decor 1. Oh no, I guess that's wall decor 2. So our very first wall decor would be 1186. Okay, so now let's see, we've got that thing, looks like that. Let's see if we can find that one. It's going to be on one of these. Could that be it? No, that's not it. Alright, so let's go to the next one. Nope. Alright, let's try the next one. I think that's it. That is it. Okay, so that's Sprite. Oh, you know what? Let's change that. Let's put this right here. 28 goes to Sprite. Because I'm going to collect all this stuff in just a second. Goes to Sprite. 1186 plus 2. Frame. 8. That's a great question. So I've written this, and so where does Python come into play? So I write the Kaitai structs in this language, and you see this is the Kaitai YAML format, and then from that I generate parsers, and this is all done for me by Kaitai. And then what I've done is I've built on top of that some memory analyzers, some UI to explore it, and I have built out all these different Jupyter widgets that let me deal with the different sprites, the music resources, and so on. And so here, these are the sprite resources, and so this takes all of the sprites that are in the Kaitai struct parses, and it puts them all into Python, and then it puts them into images, and then I've got this PIL library I've got this set of Jupyter widgets that lets me display them. And the basic gist here is that I really want to be able to quickly iterate through all of these items in order to connect them together. So if I'm right, and this corresponds to the third item, that should be frame 4 of 1186 plus 10. Let's see. And it is. Okay, so that's awesome. All right. So this now, let's take a look at this. And I should also be able to figure out where this one comes from. So this one, if all of this is right, if I've guessed it correctly, it should be 8, and it should be 38. So let's see, is there a 38? There is. It's at 1316. Ah, yes. Okay. So that matches here. It's dividing by 10, it's modding it. So they're 10 frames each. Okay, so then this one, and we've got this one. Got this one. This one. Oh, and I think that's one too. Yes, it is. Okay. All right. So I think the way this is working is it's taking the tile argument, mods it by 10 to get the frame number, and then the index of the offset into the sprites is governed by this wall decor offset. This is my favorite song on the album, Into. Okay. All right, so that... All right, so let's update my KSY file. This is not a movable object. It is a display overlay. And its arguments relate to mod by 10 to get offset index. Frame is, no, sorry. Div by, floor div by 10. Frame is mod by 10. Okay. Okay, so I think we can call that case done. Four 10 gives us 3, so what would 3 be? Yeah, it's just a little bit of a funky change to it. Okay. Okay. Now let me update my init.ksy, because this is, or sorry, no, levels ksy. This is actually not wall overlay tiles. We'll call this wall decor 3. And actually, we'll call this wall decor offsets type S2. Do I want to do a repeat? Yeah. Okay. So that gives us our wall decor offset. So, yeah. All right, I like this. Okay. Okay, so I've got that set of level rendering. I think that gets that for me. So now let's look at the different procedures here. So I did. I'm here. You know what? I'll load up Ghidra real quick and show what that looks like. So I did most of this before I got a lot of this without going through the level code, or without going through the actual source. Well, decompiled code. I got most of this from just exploring the files. But let's see. This is, I've been going through a little bit last night. It's a lot of fun. Let's see, where was I in this? Let's go to had to go through and I've named all these things, and some of them are not named correctly, and I've tried to come up with structures for them and whatnot. So I've been going through the process of trying to reverse engineer this. And let's see, where draw tiles. Draw on tile. So this is actually where it calls drawing on the tile. Maybe draw floor. Yeah, so I called things maybe if I'm not totally sure, which I guess makes sense. Yeah, here we go, draw tile. So note here the occupied. You know what? I think that's where it all happens. This is where it redraws the tile sprites and it adds things onto the tile sprites. So this occupied inside my level hash, I think, is where it stores whether or not it needs to have something layered on top. You know what, let me go to parse level. Because here's where it actually reads in the data. And I've got this init terrain offset. Big boulder, big wooden thing. Yeah. Level properties. Yeah, it offsets it with the terrain offset. Standard read file. This is where it's actually reading the level. It reads the level properties here. So edit the data type. This I'm actually going to make we'll call this wall decor. I want to match what's in the wall decor offsets, we'll say. And then we'll change this to be int 4. Needs 8 bytes. Okay, well, gotta make this to, yeah, there we go. Okay, so now I matched that to what's in my Kaitai struct. Let's go back here. So here's level properties. Wall decor offset. It is used here in load level. Check this out. If plvar occupied &40, which gets set whenever we have tile type 0, it or equals it with 40. If it's less than 193, so that means if it gets drawn, that's the tile value, I think. It shifts it to the right by 4. Okay. Ampersands it with 15, multiplies it by 2, adds 1. Okay, so this is where it actually does the offset. So it computes, so here I'm going to leave a comment here. This uses the offsets from wall decor offsets to compute the sprite to draw. Okay. Nice. All right, so now let's go back here. If it equals 1, now let's do I for item in enumerate up to the last one for I item. Oops, we want that to be I. All right, so let's take a look at what each one of these things are. So 0, 1, 2, 3, 6, 8, 17, 18, 19, and 24. All right, let's go back to my visualizer. 3, 0 is a 0. That is a tile flags level exit, and that's the one up here that sends you to the final level. Okay. The next one we want to look at is 1. All that one is a set of items. Okay, that's a bunch of items on the floor. 2, another set of items on the floor. Here, let's do this. Teleporters. Why are there 4? All right, let's take a look at 8. Oh, that's a portal info, because that's the exit, right? Let's go back here. We want to look at 0, 8, 17, 18, 19, and 24. So 8 is a level exit. Yep. 17. Teleporter destination. What? Procedure opcode teleporter enable. That's at 11:14. Or 11:4. Alright, we'll take a look at that in a second. 0:12. That's a level exit. Zero 12. It's very odd. Now, 3:12, 19 and 24. So 19. That should be the falchion. No, that's the mouth. Okay. So that is that thing right there. Oh, I'm done with the album. Let me choose a different one. So I got a little bit more time. Let's see, what do I want to listen to? How about... let's do some Ween. Yeah, I'm going to annotate this real quick so that I know where that is. Okay, so we got 12.3 is right there. So now if we want to find 0:12, oh, that's the portal info. 4:11 is my portal destination, which if I look up here, if I bring this to the front, will it show it? Maybe. I don't know. You don't necessarily need to do all this stuff either. This is really just, you know, a project that I have been enjoying, but it's not necessarily the most useful. All right, let's duplicate this one. This is, what's that, 11:4? I found there are some really cool books about low-level programming, especially in DOS, that I learned an awful lot from. That really helped me understand a bit more about the way computers function as well. So this is a teleporter destination, procedure opcode teleporter enabled. Now I'm not actually sure that's proper. It is, yes. But I will also note this is like the best that it could do, and given what I had for it, and in general, you know, it's doing a fair bit here with this. But Ghidra is a super impressive piece of software. and a lot of people have, and it's created by the NSA actually for analyzing malware and things like that. But it's fully open source, and they have a number of different loaders. People have used it to decompile stuff like Dreamcast and whatnot. There's a very common, so NES games, there's a plugin for that as well. There's 6502 software. There was a pull request to Ghidra Nest just the other day that added in support for, this is the one. There's a pull request that adds support for another common mapper. So these memory mappers, the mapper 4 just got added. So yeah, they are just directly manipulating memory, but keep in mind that this is also the result of after the compilation process happens. This is what happens in the compilation process. And then over here, this is their best efforts to try to, reverse that. And so it's, in the original code, they might have written it in, I believe this was in Borland C201, something like that. It's actually in the file somewhere. Let me real quick find it. I think it's at the start of the data segment. 3226. So it was written in C, but then, the process of compiling it, they apply all these different optimizations and whatnot to it. And I don't know how sophisticated those were back then, but presumably they were, reasonably sophisticated. And so that, what we're seeing here is we're seeing the end result of it being turned into assembly code. Yeah, it was done with Turbo C in 1988. I think I looked it up at one point, and that would have been 201, I think. So it was written in C originally. Okay. Now, why is this teleporter opcode enabled there? I'm not totally sure. Actually, you know what? Maybe that just means that's where a teleporter can show up. But then the destination? I don't know. Let's take a look at the other teleporter here. Here it is. The other teleporter, that's at 411, which is that one. But we want now to see where is that other one? Because there should be a system where it tells you where it goes to. Or there should be a teleporter destination object as well, which should be up in this area, like right there. But this one I've called a teleporter info. All right, well, let's take a look at 312, which is item 19. That's the mouth. Yep. Okay. Now item 24. That's an NPC. NPC ID 2. Yeah, that's Malachi. So that's the main guy down here. So why don't I annotate him as well? Put a circle over him. And he is at coordinates 14, 15. So I guess, is it possible that here this teleporter enable 247, 247. So here's my floor args. Teleporter dest, so opcode 00 for teleporter enable, but then F7, F7. So let's see, what's F7 if we sign it? $247. Wow. Let's try Oh, you know what? This is a fun thing. All right, np dot array 247, 255, dtype equals u1, view s1, or I1. So it goes to -9 and -1. Is it possible that it's giving relative coordinates? You know what? Let me see if I can work that out. All right, I'm gonna unpause this and we will restart our game. Oops. Exit from the command shell. What? No. I guess I gotta stop it from the command shell, huh? Well, I'm not gonna do that, but I wonder if maybe that's what it's happening, is it's not giving absolute coordinates, it's giving relative coordinates. I'll have to take a look at that. I'm gonna have to sign off in just a few minutes, unfortunately. I shouldn't have paused it. That broke the whole thing. So my teleporter destination, case 4, actually a procedure opcode. Yeah, I think this might be, I think this is wrong. It's not actually teleporter dest. I'm gonna have to rethink all of this stuff, huh? All right, procedure opcodes. Shouldn't be teleporter enable, it should probably be teleport. But we'll get to that, I suppose. Yeah. So now we figured out how all the overlays work. But the teleporter stuff is starting to make me think that this procedure parsing that I had previously is not, in fact, correct. So I'm going to have to think about that as we go forward. Thanks for stopping by, Rugs. Appreciate the company. I'm going to have to sign off now. But thanks for coming by. And yeah, hope to see you folks again soon.